Welcome to this video. In here, I'm going to explain simulation using random digits, and I'll walk you through exactly how this works step by step. If this ever confused you before, don't worry, I'll make it very clear. So, what is a simulation? A simulation is used when doing the real experiment is hard or impossible. So instead, we fake the experiment using random numbers. And there's 4 things you must include, which is very important for AP exam. Whenever you write a simulation, you need these 4 parts. First is skim, how you assign digits to outcomes. Second is count, how many digits you read each trial. Third is stopping rule, when you stop. Fourth is replacement, whether digits can repeat. So the most important idea is assigning digits. This is the part people struggle with, so listen carefully. We are given probabilities. Jockey card is 0.4, Machion card is 0.3, and Bonix card is 0.2. Prime card is 0.1. Now we use digits from 0 to 9 because random digits go from 0 to 9. That gives us 10 total digits. The key idea is that we assign digits based on probability proportions. 0.3 goes with 4 digits, 0.3 goes with 3 digits, and 0.2 goes with 2 digits, 0.1 goes with 1 digit. So we assign the 0 to 3 to Jockey, which is 4 digits, 4 to 6 to Machion, which is 3 digits, 7 to 8 to Bonix, which is 2 digits, and 9 to Prime, which only has 1 digit. And why this works? Because each digit has equal chance. So 4 out of 10 digits gives us 0.4, 3 out of 10 gives us 0.3, and so on. That's how we turn probabilities into digits. And take a look at question part A right here. We want the probability of getting at least one of each card in 10 snacks. So step 1 is count. Each snack equal to 1 digit. So we read 10 digits per trial. And step 2 is how one trial works. You read 10 digits, like 6, 8, 4, 1, 7, 3, 5, 0, 1, 3. Then convert each digit into a card using your skim. Step 3 is check successes. Ask yourself, did we get at least 1 Jockey, 1 Machion, 1 Bonix, and 1 Prime? If yes, then success. If not, failure. Step 4 is repeat many trials. Count how many successes out of total trials. In the notes, 3 out of 5 trials were successful, so probability is approximately equal to 0.6. And that's how I write all of the explanations into work. So I am going to look at 10 digits, 10 things of popcorn. I will look to see if there is at least 1 digit from each of the groups, so I have at least 1 of each card. On average, there is a 3 over 5, which is 60% chance of getting all 4 cards when you buy 10 snacks. Okay. And let's moving on to part B. Now the question changes. How many snacks do we need to get all 4 cards? Step 1 is same digit assignment. We still use 0 to 3 for Jockey, 4 to 6 for Machion, 7 to 8 for Bonix, and 9 for Prime. New stopping rule is used. Now we keep reading digits until we get all 4 types. So count digits used. For example, you read digits one by one until you've seen all cards. Count how many digits that took. So from the notes, then trial 1 gives us 8 digits, trial 2 gives us 15 digits, trial 3 gives us 8 digits, and trial 4 gives us 10 digits. Last but not least, trial 5 gives us 5 digits. So add them up and divide by number of trials, you get about 9.2 snacks. And to put everything in words, you're going to say, starting at the top left of the table, I will look at single digits until I get at least 1 from each group, representing 1 of each card. Count up the number of digits needed next trial, continue with next trial, continue with next number. And what's important about your write-up is that you're going to include the trial 1 through 5 into your conclusion. So this is important for you to put this in this order. And then the final write-up is, on average, it will take the customer buying 9.2 popcorns to get all 4 cards. And this is the source of the table. Another thing is that you can also use 2 digits to represent each probability. That will usually gives you more accurate result. And when the data is pretty large, you're gonna require more digits to help you complete. But as if for our example, we're just gonna use single digits. So to wrap everything up, here's the big idea. Simulation turns probability into digits. We assign digits based on proportions. Each digit represents 1 outcome. Then we run trials and estimate probability or average. And one sentence to remember before you turn off this video is that digits represent outcomes and their counts match the probabilities. If you understand that one line, this entire topic becomes easy.